Hey, what's up guys? So today's video is going to be about fractional indices. So before we answer the big question of what is a to the power of 1 over n, and eventually answering the question of what is a to the power of m over n, we need to first understand it from a numeric point of view. So we're going to use very simple numbers to try to see the situation of power half and power 1/3 before we generalize power 1 over n. Okay, so 81 to the power of half is the same as 9 to the power of 2 to the power of half. So 81 is actually 9 to the power of 2. And by law 3, we know that the power can be multiplied. So 2 multiplied by half is going to give me 1. Therefore, this gives me 9. We all know that square root of 81 is 9, or you can use a calculator to confirm this. And therefore, these two results tell me one thing. The equality of these two results tell me a very simple fact that 81 to the power of half is the same as square root of 81. And now I'm going to go on to power 1/3 and see whether a similar trend is appearing. So 27 is actually 3 to the power of 3. And outside power 1/3. Again, by law 3, the powers can be multiplied. 3 times 1 over 3 is going to give me 1. So this is going to give me just 3 to the power of 1. And cube root of 27, by your calculator, you can work on this, and this gives you just 3. So again, I have this situation of 27 to the power of 1/3 equals to cube root of 27. So it appears that whenever I have something like a to the power of 1 over n, on my right hand side, I have this root structure, okay, and the a being the base seems to appear in the root structure. So 27 over here appeared inside the cube root, so the a over here should also appear inside this root structure. Now 1 over n, how do we see this? So when there is a power 1 over 3, it becomes the third root of 27. So this denominator in the power appeared outside the root. Same thing over here, the power half, the denominator 2 appeared outside the root. So it's the same thing over here. If I have a to the power of 1 over n, it becomes the nth root of a. So back to what we had, for example, 81 to the power of half, it gives me the second root of 81, which is just simply, in layman's term, the square root of 81. For example, 27 to the power of 1/3. This becomes the third root of 27, which is cube root of 27 in layman terms. So we kind of conclude this result, and therefore we can generalize a to the power of 1 over n is just nth root of a. What is more useful actually is converting nth roots of a into a to the power of a fraction. Okay, in the next part, I'm going to explain what really is a to the power of m over n. So in here, I bring back the original example one more time, and we try to understand the situation of m over n. Alright, and 81, we can rewrite it as 2 to the power of 4. You can use your calculator to try to confirm this. Okay, and we can use law 3 to help us simplify the power into 2 to the power of 4 over 2. So essentially, I have a situation where this 2 over here works like the a, this 4 over here works like the m, and this 2 over here works like the n. Okay, and we already know this denominator 2 becomes the second root. Okay, so let's look at the next number, square root of 81. I can also rewrite this 81 as 2 to the power of 4. So now we have this situation where we already know that these two are the same. Alright, before this, we already know that these two numbers are the same. So therefore, let's look at this form. 2 to the power of 4 over 2 and the second root of 2 to the power of 4. So let's look at structure. This square over here is the base. I'm going to square out the base as well. So notice that this denominator in the fractional power goes to the second root. And notice that this numerator goes to the power of the base inside the root. So therefore, if I were to ask you to convert, for example, cube roots of 5 to the power of 7, then I would simply just put a base 5. The third root will be in the denominator of the power, and this power 7 is going to go into the numerator. So this becomes a very simple way for us to convert nth root or any root of a number into a fractional power. Okay, so therefore I'm going to generalize. If I have a base a, all right, and my denominator of the power is n, so it is nth roots of a. This numerator in the power m goes to the base a as its power. So therefore we have this. Now how is this helpful? I'm going to go through a really simple question as an example of how this is useful to us, and I hope this is going to help you to gain a better understanding of why you are learning this. Alright, looking at the example on the screen, we have a question on simplify x squared times 4th root of x cubed. Alright, so this kind of question looks a little bit difficult for us to simplify because the base is an unknown, and therefore it is a bit difficult for us to evaluate. It's in fact not possible for us to do so, and therefore we need to convert these roots into fractional power before we can apply one of the indices law to simplify. So there's nothing I can do with x squared, so therefore I will keep x squared over there. Okay, and what I'm going to do is to convert these roots into a fractional power. So again, this base a remains as the base, so base x remains as base x, all right, and the nth root becomes the denominator of the power, so the 4th root becomes the denominator of the power, and the power that is together with the base x becomes the numerator in the fractional power. So now I have successfully converted the 4th root of x cubed into x to the power of 3 over 4, and we can now apply law 1 where both bases are the same and separated by multiplication. I will add the two powers and I have 2 plus 3 over 4, and this becomes x to the power of 2 and 3/4 is just the same as 11 over 4. Okay, so this is a very simple example of how we can apply this fractional indices rule to help us to simplify certain indices situations. So I hope this helps you to understand why we are learning fractional indices. This should be something that can help you to decipher what you need to do in certain situations where, for example, when they have a certain number of root, let's say they have a 5th root, 7th root, how do you handle those situations? So this concludes the whole entire series on indices. Hope you have enjoyed it. Hope this have already helped you to improve on your indices and keep practicing on your indices questions. Until the next time, goodbye.